Okay, everybody, tonight we have a system of equations, two equations, two unknowns. It's not in the linear algebra sense. The variables are real valued, okay, real variables. And I think you could use maybe Lagrange multipliers, probably partial derivatives, set each of the derivatives equal to 0 and solve it. But the algebraic structure here turns out to allow us to solve this problem in a slightly easier fashion. We're supposed to minimize the sum x plus y. So as a lot of you probably noticed, there's some very simple factorization going on right here. The second equation after you factor just becomes this statement right here. And of course everything's quite convenient because the difference of the two variables, 20, is given, and so 20 squared is 400 right here. Then x minus y is 20, and then the rest of this, you subtract 400, you get 57,600, and then 20 still on the left hand side. And when you divide through by 20, you get y squared is equal to 2880. $2,880. Now notice this has a sort of a convenient representation. It's divisible by the perfect square. 24 squared is 5. Let's see, 24 squared is 576, right? And so if you divide this, or I'll just write this out, this would be 576 times 5, right? And let's check the arithmetic, just make sure I got that right. 5 times 576 is 2,500 plus, that'll make it 28. Yeah, this is correct, isn't it, folks? Yep, 5 times 576 is 2880, 2,880, right? Okay, so of course we can take the plus or minus square roots here and get y is equal to plus or minus 24. Again, 24 squared is 576. 24 times 24 is 576. You can do the arithmetic on that. And so you get plus or minus 24 square root of 5. Okay. Now that's our value for y, but remember we are trying to minimize x plus y, right? Okay, so you can see if you continue on here, you would get x plus y. I think I have room here. Yeah, you would get x plus y, which is what we're interested in minimizing, right? X plus y is equal to 20, right? That 20 is coming back because that's just the relationship between the two variables, right? X plus y is equal to 20 plus or minus 48 root 5. Now there's more than one way to think about this. I would tend to look at it like you have x minus y right here, so x plus y is equal to x, or is equal to 20 plus x, is the way to look at that. Okay. In other words, again, we have x minus y right here, so if you add 2y to both sides, you get x plus y, and that's where this comes from. Okay. Now we were asked to minimize. Now this is kind of anticlimactic because there's only two values, right? There's nothing to select from here. So of course we're going to pick the minimum value to be 20 minus. Yeah, this is a competition problem, I think, from the Singapore junior section back in 2020, just recently, I think. And it's a little misleading to think this is how the problem would go. You know what I mean? Because most of the time when you see something like find the minimum value, maximum value, you often think of calculus. But so many of these competition problems it's set up to where you don't have to employ calculus just because of the algebraic structure of the original system. You see, this thing was literally designed to work out. This looks kind of nasty, but the fact that there's a common binomial factor of x minus y is what makes it work, okay? And so you see, if you're defining the minimum value of x plus y, well, there's only there's two possibilities. One of them's negative, one of them's positive, so you choose the negative number, right? So in that sense, it's very puerile. It's very naive. You know, you're not doing anything sophisticated, you know, like partial derivatives, Lagrange multipliers, any of that kind of stuff. You're just simply following your nose, doing the algebra, making the appropriate substitutions, and voila, there's only two possible solutions. So if I had to ask for the maximum value, of course, the solution would have been 20 plus 48 root 5. Okay? All right, so again, these are kind of sneaky problems. A lot of the higher level math people don't enjoy these problems so much because these kids are trained to know it's like a big bag of tricks, okay? You don't do the natural thing. This problem is similar to something where you learned a trick, and some people don't believe that's the best way to learn mathematics, you know. So in fact, some of the most prominent mathematicians don't think competition mathematics is towards becoming a good mathematician. You're just being trained to answer a certain ilk of problems. But anyway, let me know what you thought about this process and if you agree with that. I tend to like these competition problems because they're challenging. There's usually one little thing that you don't think of and you sit and stare at it, or at least I do, for 2 hours, and then you finally have to look at the solution. On this one, I figured it out, but on most of the others, I don't. I have to I look and get frustrated, and I finally look at the solution and go, why didn't I think of that? You know, but it's just because it's a problem that's designed to work, and you have to be in the problem composer's head, really. It doesn't necessarily mean you're going to become a great mathematician and get published in some periodical, right? It just means you're good at working these type of problems where you have a big bag of tricks that you've memorized. Okay, but again, let me know what you think in the comments.